Good morning or good afternoon, as the case may be. My name is Sosale Mohana. I'm a maths teacher who has taught maths for over 50 years in 3 continents and 3 countries, like India, in Asia, Kenya in Africa, and England in Europe. I've just retired a couple of years ago, and I thought I should use my experience to record and deliver a number of lessons based on the British curriculum for A-level maths, so the students who want to reinforce their learning can use it. I have a master's in maths, of course, way back in 1969. I completed my master's in maths, and then I did my teacher training in 1974. I've been working since 1969 till 2019, clear 50 years. So I hope these lessons are useful to you, and you're welcome to watch them, and then with each lesson, there will always be a document which covers whatever has been done in the lesson, so you could use that perhaps as your own notes, or maybe to go over what has been taught during the lesson. I hope you enjoy the lesson. Hello, this is the 3rd lesson on functions. I'll just take one example, and then of course, when I give you the handout, it'll have a couple of more examples. Ultimately, of course, when we do, we might come across inverse functions later. I'm not too sure, unless we do further maths, of course. So at the moment, let's look at, we're still in topic 3. And this is about examples of questions on functions. I'll just take one example to show you. Given that, I'll write it here because I need that space to work. Given that f of x equal to 1 over x, x belongs to R, x not equal to 0, g of x equal to 1 minus x, x belongs to R, h of x equal to x over 1 minus x, x belongs to R, x not equal to 0, x not equal to 1, and then j of x is x minus 1 over x, x belongs to R, x not equal to 0. Let me not use x not equal to 0 here. So you're given those functions, and you are asked to find so many things. So I'll take each one. Everything is based on those 4 functions. Part A. Show that g squared of x equal to 1 minus x. G squared 1 minus x. So what is g squared of x? G squared of x is not g of x times g of x. You're not squaring 1 minus x, but you are using g of x inside g of x, meaning it is g of x, which is equal to x, which is g of 1 minus x. What does g do? Which would be 1 minus x, which is x. Now, there's something I purposely didn't mention. I left it for this lesson because I thought some of you will have figured out. Remember, if f of a is b, then f inverse of b is a, correct? So in other words, f inverse of a is a. F inverse of f of a is still a. So when you operate a function with its inverse, you come back to your original value. So g of x is x, which is g squared of x is x. So therefore, g inverse of x equals g of x. G is called a self-inverse. If f squared of x is is x, then f is a self-inverse. So g of x is x. So that means whatever is the effect of g, when you do it again, it goes away. So therefore, g inverse of x is g of x. Right? So I will of course put in the handout this definition or this concept that f of f inverse is that. Now let's do this. Find fg of x. Fg of x and gf of x. What is fg of x? Means f of 1 minus x, which is 1 over 1 minus x. Then the domain of fg is the domain of g. What is the domain of g? X belongs to R. But this, when x equal to 1, you are dividing by 0. So you need to add a condition x cannot be 1. Even though the domain is there, the function will not be defined at x equal to 1. What is gf of x? Will be g of 1 over x. Correct? Because you take f, put it inside g. Here you took g, put it inside f. What does g do? 1 minus, in place of x, you write 1 over x, which is x minus 1 over x. What is x minus 1 over x? Which is j of x. Here, x belongs to R, x not equal to 0. And of course, I had given x not equal to 1. That's not necessary in this case because I'm doing gf of x. You can't divide by 0. Then, the last bit says, show that g h of x inverse, g h inverse of x equal to h inverse g inverse of x. That means find gh, find its inverse, you get an answer. Find g inverse, find h inverse, operate one into the other, get another answer. Show both answers are same. There's another way of proving it, which I'll show you in a minute. Let's do this first. What is gh of x? Gh of x means g of h of x, x over 1 minus x. What does g do? 1 minus x over 1 minus x, which is 1 minus x, 1 minus x minus x, which is 1 minus 2x over 1 minus x. Right? What was the domain of h? Domain of h was x belongs to R. So here x belongs to R and x not equal to 1. What happens is x keeps on changing. When it keeps on changing, later on you will realize that the value approaches y equal to 2. How would I do that? At the moment, let's not bother about the range because I'll come back to it when we do the rational functions. That's the problem with A-level maths. When you start topic-wise, somewhere you want to do something new, and unfortunately, I haven't done something which needs to be done. But when I go to do that there, and I come back here, again, there will be something else that is missing. So I have to put a restriction somewhere. So for the moment, let's not bother about what happens with the graph of this. I'll show you the graph of this. Incidentally, later on you will learn that the graph of this x equal to 1 is an asymptote. And then when x is 0, y is 1. And then as x tends to infinity, 2x or x, y equal to 2 is also there. So therefore, this graph goes like this. The range will be, you will learn this graph in the next couple of lessons. So for the moment, I have to assume. So therefore, the range is, I don't need this because I'm just proving that, but I would rather show you where the range could be written. Range is y belongs to R, y not equal to 2. It can never be 2. Now I need to find the inverse of this. So if I can rub this off, gh of x was 1 minus 2x over 1 minus x. So I call that as y. So 1 minus 2x equal to y times 1 minus x. So y minus xy equals 1 minus 2x. So 2x minus xy equal to 1 minus y. So x times 2 minus y equal to 1 minus y. So x equal to 1 minus y over 2 minus y. So gh inverse of x will be 1 minus x over 2 minus x. So you first find gh of x and then find its inverse. Okay. So it is 1 minus x over 2 minus x. I did that. gh inverse of x. Okay. But then I have to do the other one. First find g inverse of x. We did it in the beginning, so start with y equal to 1 minus x equal to 1 minus y. So g inverse of x is 1 minus x. And I want h inverse of x. To do that, y equal to x over 1 minus x. So y minus xy equal to x. So take this to the other side. Y equal to x plus xy. So x times 1 plus y equal to y. So x equal to y over 1 plus y. So h inverse will be, h inverse of x is x over 1 plus x. Very good. Now, having got that, I need to find what is h inverse g inverse of x. H inverse g inverse of x is h inverse of 1 minus x. That will be 1 minus x over 1 plus 1 minus x, which is 1 minus x over 2 minus x. Can you see that? Of course, you can obviously say x belongs to R, x not equal to 2. Oh yeah, once you do this, you obviously realize that x can't be equal to 2, so you can even write it using that. So that is how you use inverses. So most important relation is fg inverse equal to g inverse f inverse. I don't know whether the lesson is taking too long. I just want to, because that's a question which comes in the exam. Show that g inverse, this is a standard proof which you should know. Show that fg inverse of x equal to g inverse f inverse of x. You are asked to show that. So to do this, let's assume fg inverse of x is some function h of x. So therefore, remember, a function with its inverse gives you identity. So I can say fgh of x equals x. Correct? Now, I want to find what is h of x. That means I need to get rid of f. So can you say f inverse fg of x, fgh of x equal to f inverse of x? Now these two, they cancel each other. So I get gh of x equal to f inverse of x. Now I want to get rid of g. So I'll do g inverse g h of x equal to g inverse f inverse of x. These two cancel each other. So h of x equal to g inverse f inverse of x. And what did I call h of x as? Fg inverse. So that's equal to g inverse f inverse of x. So that is how you show inverse of a function. And this I've come across in a number of question papers. I think mainly in, I don't know, some of the OCR papers I've seen it once somewhere in CIE and once in EdXL too. And it's very common in Indian papers, obviously. So, well, that's a short course on functions. And the handout will have some examples which you can practice upon and then cross-check with the answer in the handout. Thank you. Bye-bye. Hello. I want to take this opportunity to propose a vote of thanks. I would like to thank Vivid Innovations Private Limited and Commerce Forum for so generously giving up their studio and the facilities and the services of their technicians to record all these videos for free. I think that needs to be acknowledged and appreciated. Thank you very much. And my special thanks to Mr. Nitin Mahadevappa, Mr. Nishant Guruswamy, and Mr. Sadan Kumar DN for all their help and assistance in getting these videos ready, uploaded, and launched. Thank you very much.